You're moving away from the world of solving equations and onward and upward into this relationship called relations. And by the end of the video, you should be able to look back and say, yeah, I can represent a relation in these four different ways, and I can determine whether a relation is a function or not. I'll display these again at the end of the video and we'll see if it's a success. So we're going to begin with a very friendly equation, y equals 2x minus 4. Nobody's afraid of that equation, and we're going to use it to get used to what's going on with a relation. You're used to taking an equation like this and say plugging in a 3. If I plug in a 3 for x, 2 times 3 is 6, 6 minus 4 is 2. So plugging in a 3 leads to an output of 2. You're maybe familiar with making these t-charts, but we can think of these t-charts as if I input a 0, I get out a negative 4. Plug in a 0, do the math, get out a negative 4. And I can do the rest of the way. And this relationship between the input numbers and the output numbers is what we would call a relation. And you can think of that as input the x, output the y, input output, or you can also think of this as domain and range, which is going to make more sense as we start graphing these and taking a look at pictures. So this relation right here, I've displayed it as a table, but we can display it as a diagram. If I plug in a 0, I should get out a negative 4. All these are just different ways to show the relation that's happening. And finally, you can take any one of these and make a list of ordered pairs. I'll show you that here. I'm going to pause it while I write these. This is the same relation that we're looking at up here in tables and diagrams, now in ordered pair form. That's nothing new to you. And then, as you know, you can always take ordered pairs and graph them. So I have the ordered pair 0, negative 4, which would be, boy, we have to go down here a little bit. There it is. We have 3 comma 2, so over 3 up 2, 4, 4, and 6, 8. I'm just taking all of those points and I'm plotting them on the coordinate grid. And in this case, it makes this beautiful linear pattern. So this relation can also show up as a graph. But whether it's a graph or ordered pairs, a table or a diagram, they're all different ways of describing the relation that you see here. So now you're looking at a new scenario. We don't have the equation that led to this relation, but that's okay. You don't have to have that equation. You just know that in the case here, I see my inputs and my outputs. I could put this into a table, a t-chart, ordered pairs. One way to think about this is the domain is the input and the range is the output. Another way to think about domain and range is the domain is the x values and the range is the y values. So we're just doing a bunch of different ways to describe the same things, but in this case, my domain is the set. There's a fancy notation that means we're going to have a set. It's this group of numbers, 2, 4, 5, and 8, because they would be the input, and the range is the output. In this case, 5, 17, 26, and 65. And of course, we can make a pretty picture out of these. I'm going to go ahead and pause this while I graph these. So I went ahead and graphed these. Just one example. This 5 input, output 26. If I felt like it, I could think of that as an ordered pair 5, 26, which means I went over 5 on the x-axis, up 26 on the y-axis. And this relation, if I take a look at this, you see that that pattern is not linear. And there's no rule that says a relation has to have a linear pattern. The last thing we want to do is address the question that, is the relation that we're working with a function? So a function is just a special type of relation, and most of the time when we're working with equations, they will be a function. So let's take a look at what determines if a relation is a function. A function has only one output per input. Okay, you may not like that definition, so you could look at it another way. Any x value, which is your input, can be paired with only one y value. Okay, that still might be awkward, so let's start taking a look at what would make up a function and what would be not a function. So in this case, each x value only gets one y value, so that's a function. And the ones we've been working with so far have been functions, so nothing here looks new or shocking to you. But let's take a look at this other one, this not a function. You see that the 2 input leads to an output of 10, but also later on in the table, the 2 input leads to an output of 26. I'm going to graph this for a second, so hold on. I've graphed 3 of the points. I've graphed the 2, 10, the 4, 18, and the 8, 34. Those are the 3 points. I haven't graphed the 2, 26, but I'm about to do that. This says 2, 26. Well, this is what tells me that I don't have a function in this case, because for this x value of 2, I went up and I saw that I got 2 different y values. And that is illegal procedure. That is not a function. Anytime you've got 2 different y values for a given x value, it is not a function. I'm going to give you one more set of examples of what would be a function and what would not be a function. This one is not a function because if you take a look, an x value of 10 leads to a y value of 70 or an output of 70, but it also leads to a y value of 140. So we've broken the rule that says any input or x value can only have one output. Here it has 2 different outputs, so it's no good. This over here is a function. Looks like we've got some funny business going on, but it's not a big deal because each one of these x values leads to one single y value. The fact that the 30 and the 40 both led to a 75 is okay because the 30 didn't get two separate y values, or the 40 didn't get 2 separate y values. I know that can be a little confusing, and it's not going to be a big deal throughout this whole chapter. But if you're ever asked, is it a function, you need to rely on this definition or the simple fact that any x value that you see can only get one y value. If it has more than one y value, that's not a function. All right, I promised you that at the end we would go back and see if the video has accomplished the goal. And these were your 2 goals. Can you represent a relation in all these different manners? And can you tell the difference whether a relation is a function or not? That's the introduction. The next video is going to show you how this relation and function information can be applied to model a real scenario. See ya.